All right, we're live.
He's lucky I love him.
Okay, so any questions on the homework under the preparation?
Uh-huh.
I actually have a question on number 13.
That's actually what I was going to ask too, 13.
Oh, that one's actually pretty easy. So
Okay.
if you go to your graph, the scatter plot, and you go to the dots on the scatter plot, it'll give you the number. So if you try to hit 51 on there, if you hover over that dot that says 51, it will give you the 343.
Oh, wow.
Hold on the scatter plot, I'm hovering over, nothing's happening.
On the Excel sheet, I think.
Yeah, on the Excel sheet. Because mine, if you hover over it, it will give you the. Have you clicked on your Excel sheet to make it active?
Oh my gosh, active?
Well, if you go to a different window, it's like your Excel sheet won't work if you're. Just click on your Excel sheet and then anywhere on your Excel sheet, and then go hover over the dots.
Okay.
Scatter plot.
So when I hover over them, I get a box that comes up. Like this one box says Series 1.4.33.
Right. So that series point, that's your point 49. So it's asking you what 51 is. So find the one that's 51. If you go down below, you'll see 50. Kind of follow that up and then look at hover over it. Your point is 51 that you're looking for.
Oh, I understand.
And then you'll see the two numbers below. It'll say 51, comma, and then it's 343. 343 centimeters is what you're looking for.
Okay.
Does that make sense?
Yeah. All right. So that really is simple. So then my next problem then is explaining why the values in 8 and 9 are different. But we didn't get values in number 8. Did we?
We did.
I can't find you guys. So my number 8 is to create a scatter plot. Am I looking at the wrong thing?
Mine is to create a scatter plot too.
Yeah.
I to tell you the truth, didn't do 15, so I can't answer your question.
Okay, so
I
Courtney,
did it. I'm trying to. I did it. Let me find it.
I mean, I looked at the answer, but it doesn't help me. You know, just having that answer doesn't help me with figuring out what we're supposed to know.
Did you watch the video? The guy, he was the same way. He said the same stuff, and I was like, it didn't make sense. So I just didn't do it.
So for number 15, well, I had it once. I have so many things open. I'm trying to finish my
Sorry, I'm trying to find mine.
I think
okay, so number 9, you have a y-intercept.
Yeah, but the question's
you have a
asking,
number.
The question says, why are the values you obtained in number 8 and 9 different? But number 8 is a scatter plot.
Yeah.
She's upstairs on my burger.
He's
So
eating your burger.
I don't know.
Okay.
needs milk, so check on him as soon as
Okay.
it's coming out of there.
All right. Okay. Sorry, my husband was talking to me. Okay, so so you're looking at 51 for number 8. You look where 51 is. Okay, how do I explain this? 51, and you see it's above the line. And then, how do I explain this?
Well, okay, Courtney, there's no 51. Like, the question says, why are the values you obtained in 8 and 9 different? And explain. But when we did a scatter plot representing the relationship between the head length and the body length, there's nothing about 51 there. And then when we use the software to compute the value of the y-intercept, we got a negative 69.369.
369, yeah, that's the y-intercept.
So the question says,
CJ, you're okay.
why are the values you obtained in numbers 8 and 9 different? So to me, it almost is if this question doesn't, it's not lined up right.
Yeah, I'm not sure what numbers they're looking for is the.
Right. And I mean, maybe all the dots on the scatter plot are all the numbers, but unless we did like what you did in number 13, unless we're hovering over one specific one, we're not getting a value for the dots.
I think that's what we're supposed to do and compare.
So, I mean, we could just let it go and try to find the answers on our own.
Yeah, I have no idea, honestly.
Yeah, it's,
I don't know either. That's why I left it blank.
yeah, same here. Well, because in number 9, we can compute the value of the y-intercept. That's one number.
Hey, Dad, can you bring me my calculator?
Did you guys
Dad.
look at the answer key at all?
Can you grab my calculator?
Yeah, I have the answer key.
Yeah, because it's like, it's not making sense to me though, because it does mention the 51 centimeters, but why is it mentioning that, like you had said, Kelly, if
Right.
that's not in the problem?
So I understand the values are different because the points are not all exactly on the line of best fit. I get that, they're scattered. But if you look at the graph visually, you can see the actual point of 51 is notably above the line. To me, this question doesn't fit with what we've been doing. And it's totally possible that it's, you know, been messed up over time. And so then I wonder, what was the answer for number 13?
343.
Oh yeah, so that doesn't, oh, so, okay. So I'm wondering if number 15 was supposed to be, why are the values in number 13 and 14 are different? Because when you do the math, when you use the y-intercept equation, you get 308.031.
Yeah.
And 308.031 and 343 are numbers that we could be comparing. So my thought, and it also gives us the 51 centimeters. So my thought is that number 15 is supposed to say, why are the values you obtained in numbers 13 and 14 different? And then it makes sense.
I don't know. I could probably shoot an email to the teacher and ask.
Right. But do you understand, if we change the question on our own, before we email her, if we go to the question and if we say, why are the values you obtained in numbers 13 and number 14 different? then the answer fits. It works.
It makes
And it
sense.
works
to do that.
just like he showed us in the video. I just think that
when in the video, I can't remember, did he say he was comparing 8 and 9 in the video? Do you know what I'm saying?
I don't think he said 8 and 9. I think he just compared using the scatter plot, using the computer, and using your calculator. Because we'll always get a different number when you use a calculator.
Right.
And the reason being is because when you look at the scatter plot, just like the answer says, that point for 51 is actually above the line. So it should have a greater number than when we do it by hand.
Yeah, I can't really answer your question because I don't know.
Right. So the important thing that we should take from this, whether it's 8 and 9 or 13 and 14, is the reason there is a difference. And the reason is because of where that exact point lies. Does that make sense?
Yeah.
Okay. Courtney, are you tracking? Okay. You guys want to go to the quiz?
Do it.
I'm tracking.
All right.
Oh no, I don't want to open that one. I opened up the wrong one. Don't save. I want to open up the Quan.
Does anybody sweat a little bit when you see if needed? Here's the normal probability applet.
No,
I don't
not
like
anymore.
that. Although I'm catching on now. Math
My
doesn't
first
stress
thought
me out
was, why are we needing that? We haven't used it in the homework yet.
because we could
Every
need it.
single quiz, but we don't
We could
use
need
it.
it. All these lessons are cumulative. We have to remember that.
Yeah, I don't like that at all.
There was one question on the previous exam, the one we just took, that took us way back. Like, I don't remember the exact question, but basically, you know, what is mu and it equals p or something? And oh my gosh, I sat there looking at that question. It's like, I don't even know what to do. It's like, okay, hold on. Way, way back. I went to the very top of my little sheet. It's like, okay, I'm catching on again.
Yeah. It's hard to remember everything.
I know. Okay. You guys ready? Number 1 and 2?
Yeah. I keep opening up the wrong dang spreadsheet.
Oh.
Come on, Courtney, you got this. Third time's a charm.
So number 3 is at 2.0.
Yeah, I just put 2.
Number 4 is 1.5. Did you get 1 for number 5?
I did.
Okay.
How do the math self-efficacy data sheet?
Control copy.
So
Control paste. Don't you start as bull hunty.
You
Control
said you got 1
paste.
from 5, right?
Yeah.
yeah.
Control. Copy.
So for your math stuff, is it? I
Control paste.
don't see any kind of food on that.
Any kind of food?
Well, for number 6.
Yeah.
I'm looking at it
so
right now.
pull up the math self-efficiency.
Yeah.
It's a hot dog.
Yeah, I think it's a hot dog also.
Well, where did you get that at?
So in the middle of the
The scatter
textbook,
plot.
in the middle of the textbook, well, about 2/3 of the way down, there's a chart with 3 graphs on it underneath the manatee. It's just above 3.1.
So what does that have to do with the data for the?
So you got 3 shapes. You have a hot dog shape, a hamburger shape, or a banana shape. And
Oh, I see what it's. Okay. Yeah. Sorry.
no, don't be sorry. When
I mean, because it's a hot dog.
I'm like
Number
what
7's the first one, right?
I think it's a hot dog also. It's not a banana for sure. So for number 7, I don't know. I think it's the second one.
I thought the hamburger and the banana are the ones where it's not used. Or it's not appropriate. I think for the
hamburger and the banana
hot
linear
dog,
is not appropriate.
it's appropriate for the hot dog. But for the
Well,
hamburger and banana, it's not appropriate.
you have to conduct your regression analysis to determine if there's a significant linear relationship. And so I think very basically the first one is right. Simple linear regression is appropriate. But I don't know. And I went back through the reading. I did not rewatch the videos. But I just am not sure on this one.
Hold on, I'll pull it up again. I don't have my notes down here. They're upstairs. Statistics test.
I know for sure it's not the third choice.
Shh. Sit down. Okay. Hot dog shape, linear pattern. Conduct regression analysis to determine if there is a significant linear relationship.
Right.
So it's appropriate. It's got to be appropriate.
Okay. So the first choice?
Yeah, because the others are the only options are the parent random scatter, which is the hamburger, linear regression is not appropriate, and the banana linear regression is not appropriate.
Right.
So I guess it is appropriate.
Okay.
How many observations are in the data? Does it tell us that?
I think 6.
X equals 6.
Yeah.
That's what I've got on the.
That's what Excel says.
Yeah.
CJ, stop. Where's that at on the? Where are you at?
On the t-test for linear regression Excel sheet, it's the box of numbers just above the scatter plot.
Oh, right there. X equals 6 above the scatter plot.
But the other way to look at it too, guys, is to look at your scatter plot itself, and the data only goes over to 6.
Shh.
Just to let you think about that.
The y-intercept is CJ, stop. B.
So I got 18.690.
1.296.
You got what was it, Kelly?
18.690.
Okay, so when you put in your information, was your, because I got 1.296. Did I do it backwards?
Yeah, I got 1.296.
Just when you entered your 2 columns of variables.
Yeah, so when you entered your variables, did you do the score is X and then the confidence rating mean is Y?
Maybe not. I'll have to go back and look. The score
Are we
is
sure we did
X.
that right, Courtney, on that side?
Yeah. I got 1.296 and the slope is 0.042.
So the confidence data is the explanatory variable and the score is the response variable. So the score should be the y variable.
The score should be the y variable.
Yeah,
So then I put mine in backwards.
it's what it sounds like.
Okay. So let me flip them around real quick.
Okay.
What's wrong?
The
Is that-
variable
Is it backwards?
The
Yeah.
confidence
Okay,
data.
CJ.
The confidence data is the explanatory variable, which is X, and your score data is the response variable, which is Y.
So I just got them backwards.
Yeah.
I'm guessing. So your first explanatory variable should be 4.34, and your first response variable should be 50.
Right. I'm switching it just a second. Ugh.
Oh, crud.
Sorry, which number are you?
CJ,
Number
stop.
9.
Okay.
CJ.
Doesn't the Excel sheet just give us the y-intercept?
What's that? Nathan?
Doesn't the Excel sheet just give us the y-intercept?
Yeah, but we disagree on the proper order of numbers.
What are you guys debating between?
So I put my columns one way and Michelle and Courtney put them the other way.
So it's 18.690.
That's what I think it is.
And then 12.695.
If we did it right, yeah.
Well, if we don't get it right, then we know that it's the other way around.
Right. I'm pretty sure.
690.
Okay, sorry, can you say it one more time what you guys got?
So it's 18.690 for the y-intercept.
For number
And
9.
then the slope is 12.695. So
What were the other options? Because I have something else showing up in mine.
well,
Like what did you guys have that was different?
when I put it in before, it was like
1 point something.
yeah, 1 point something.
So weird.
I
I'm
got
getting
69.47 for number 11. Is that what you guys got?
Yeah, we're trying to help Nathan still.
my y-intercept's telling me it's 74.881.
Oh, why is that?
So does your X variable column start with 4.34?
No.
So the explanatory variable column is 4.34, 4.73. Assuming you're using the same data that we are.
Did you pull up the right data?
The math.
Let's plug in the wrong. Oh, we're supposed to put the confidence rating in, huh?
What?
We're supposed to put in the confidence rating mean.
Now, are you using the t-test for linear regression Excel sheet?
Yes, so on the math self-efficiency, was it confidence rating mean that we were supposed to use?
So you put the confidence in the X variable and the score in the Y variable.
Oh, darn it. Okay, that's why it's wrong. Okay, move on. I get it now.
Okay.
Yeah, that's what we were debating before. I was like, so is that switched then, or is it backwards, or do you just flip it over?
For some reason, when I was plugging the numbers in, I just put completely wrong numbers. So
Then for 9, you got 18.690.
yes,
That's what I got.
And then 12, you got 12.695.
yeah.
Okay.
Number 12?
Or for 10, sorry.
Yeah, 10.
Yeah. Okay, so then 11, we just take those two numbers and add in the 4, and we get 60. Well, we have to multiply it in, but 69.47.
That's
That
what I
said, Courtney?
Is that
So
what,
then number 12.
okay.
So the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What's the maximum predicted value of Y for these values of X? And I don't know.
So is that the predicted value? So is that where we would go? No, that's not.
The largest X value is 5.97.
How'd you get that?
I looked at the chart.
What chart?
The scatter plot.
The
Is that
Excel
that
sheet?
one thing I showed you?
I didn't look at the scatter plot. I just went through the data. And, oh no, it's 5.83. Just kidding.
How did you get that?
No, it's 5.97. I was right the first time.
Oh my gosh. Okay.
Because
So
I just went through the X. I just looked through the numbers and figured out which one was the biggest one. I literally just looked through the data. And it's 5.97 is the biggest one I found.
So isn't this where we use the equation, the B, was it B naught plus B1 times X? No?
Let me
Anybody?
see if.
well, that's what we did on the one up above. So do we do that again on this one?
Well, I don't know because I don't think we have a solid X unless it's.
CJ, stop. Stop.
So the confidence data
Okay.
resulted from students evaluating their confidence for each question on a scale of 1 to 6. So what is the maximum predicted value of Y for these values of X?
Don't. Go out if you're going to scream. So I think we take the numbers up above and we plug in the 5.97 and that'll give us our Y. Stop.
Where did you get 5.97?
Yeah, you need to let us know what you're doing because I'm not sure where you're getting.
It's number 90. It's number 90 on the data sheet.
90 on the data sheet.
Yeah, on the Excel sheet.
I don't understand.
When you enter the data on the, here, let me see if I can show you.
Okay, so I go down to number 90. And I got,
I can't even see my own self. I don't even know what's going on. Hold on.
So I guess I still am not tracking when you say you go down to number 90.
Okay, look, right here. Number 90 is 5.97.
so how did you know to go there? Because I remember something like that in the.
Yeah, I was gonna say, is there an easier way to figure it out other than looking through every?
I don't know. I'm on the linear regression thing, and I literally just looked through and figured out the biggest number, and the biggest number is 5.97.
So you just kind of glanced through all those and then looked at them and.
Yeah, I looked through all of it, and then figured out the closest number to 6. Well, there is a 6 right here, I guess. That's the biggest one is 6.
That is the biggest one. That's given to us in the problem.
Yeah, right there is 6.
Your choices are 1 through 6.
Yeah, so 6 is the biggest number. So we plug in 6 for x and then solve. So we use the numbers we got up top.
I just asked if that's what we were supposed to do, guys. So we're supposed to use the problem, and instead of having it be 4, instead of x equaling 4 for the previous problem, we have it equal 6 times.
Yes.
Do you understand,
Oh.
Michelle?
Yeah, I know what you're doing. So you just take that whole thing and you multiply it by 6.
Mm-hmm.
So the 12.695.
But it's going to give
18
you
plus 6, 9,
So 94.80.
plus
94 point what?
86.
94.86. CJ, stop it. Daddy's at work. He's throwing a fit. He wants his dad. How many explanatory independent variables are present in simple linear regression? How many
So I thought I was
independent
right, but
variables?
then I think I have them mixed up. I think there's one dependent variable, but I think there can be more than one independent variable.
Yeah.
But
Because you
is
can
it-
have it B1 plus B2, B3, B4.
So more than 2?
There's
or
only
2?
one Y. There can be more than 2. At
So
least that was shown in the example.
For the explanatory variables, there can be more than 2. Right?
I'm reading it right now. Hold on.
No, I reread it too.
Uh-oh, Michelle's gone.
Nathan, are you getting all this?
I'm still looking for this answer. I'm looking for the reading.
For which one?
For the one we're on right now.
Oh,
I think there can be more than 2. Because it says up at the top like how you can have B1, B2, B3. I think it can be more than 2.
for explanatory. For X. Right?
Yeah, I'm going up more. Hold on. I went to the bottom to read the summary, but it wasn't very helpful, so now I'm going back
No,
up to
you
the
have
top.
to go up a little bit.
Explanatory variable is the independent.
Is it cold at your guys' house?
Yeah, it was 23 degrees this morning.
Yeah, it sucks.
She's back.
Sorry. I don't know why I have so
No, you're
many
fine.
issues.
I think it's the weather.
So we're looking to see if X can be more than, if it's 1, 2, or more than 2?
Correct. And we need the same for Y. Because the next question is for the dependent variables.
Well, X would be more than 2, wouldn't it? Like in the past problems, we've used 4, we've used 6.
Right.
So for 12, was it 5.97 then? I could figure
94.86?
94.86. Hold on, let me. 18.
Courtney, did you get that for 12?
694.
For 12 is, let me see. Oh, sorry. Let's see.
94.86.
I think.
12, I've got 94.86.
Yeah.
Okay, so it wasn't the 53 point whatever.
No.
So are you on 13 or did you move up?
No, that's what we're trying to decide.
Okay, so this is introduction to multiple regression. If it's a multiple regression, then it can be more than one.
Right.
I think for the single regression, there's only one.
So for simple linear regression, there's only one for the explanatory independent. And then there's only one for the response dependent.
Yeah.
So 13 and 14 are both one.
And so what would it be if it was like multiple linear regression?
What's
If
that?
there's multiple, y would always be 1, but there can be multiple x's.
Okay.
So 13 and 14 are both one.
Because for multiple, there would be, the example they give here is in multiple, there's the initial speed of the initial speed of the car, which is I, the weight of the car, which is I, and the amount of the tread of the tires is I. So that would be multiple. You can use, on the multiple, you use more than one.
For the explanatory. For X.
Mhm.
So I've talked myself out of every answer for 15.
Let me hold on and look. I was just rereading that. Okay, 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce. Hat size, circumference of the hat, and length. Meaning the company wants to predict size of hat. What is the response variable?
So the response variable doesn't change. Right? Or that doesn't matter. Yeah, it does matter. It's dependent. Everything's dependent on the response variable.
So would it be the circumference being used to predict the size of the hat?
I don't know. I can rationalize every single one of them.
I think it's the circumference.
That's 2 for circumference. So the measurements they collect include the hat size, the circumference of the hat, and the lengths of the major and minor axes.
Oh, hold on. They want to predict the size of the hat given the circumference.
So if you're
So
given
circumference would be
what will the size
y,
of the hat be?
and the rest would be the rest of the variables.
So the circumference, because it's being used to predict the size of hat.
Mm-hmm.
That's what
Yeah,
I'm thinking.
that's what I think.
The last one?
Yeah, but I'm
Yeah,
not bet my life on it.
Okay, I will be brave and I'll submit this.
All right, go for it. We'll watch you freak out.
15 we got wrong.
Yeah.
And then I can't see. Go away, thing. I don't know what you are.
So would it be the circumference because it is the variable being predicted?
Hold on.
So.
Did we get other ones wrong, Courtney?
8.
Number 8 is wrong also. So
we got
6,
8 and 15.
Did you put number 6? Did you put 6 for number
Mhm.
8? Okay.
Yeah.
So the company wants to predict the size of the hat given the circumference. So they have the circumference. Now they want to predict the size of the hat. So what's the response variable?
If
The
it's
circumference, because it's the variable being predicted?
no, because they have the circumference.
So the size of the hat because it's being used to predict circumference.
No.
No?
So because it's saying they're trying to predict the size of the hat given the circumference. So they're not using the size of the hat to predict the circumference. They're trying to predict the size of the hat already
So
given.
they decide the first one, the size of the hat because it's the variable being predicted.
Yeah, I think just from how the question is being asked, I think you can already eliminate 2 and 3.
Okay.
That's my personal opinion. I don't know what everybody else thinks, but
All right. We've got 3 more chances to get it right before we're all wrong. All right. So let's go back to number 8.
So I'm trying to go back in and enter all my data.
Yeah, I lost all
Number
my.
5 is 1.
How many observations are in the
Number-
data?
Let me go back and see if I can get it up.
Hot dog.
You lost all yours too, Michelle?
I lost the Excel because
Oh,
the computer froze. So I can open it back up and get back in there real quick.
I think the observations is how many things there were, and there is 142.
see, I thought that also. Initially, I thought that, but wouldn't that be given in the data somewhere?
I don't know.
So you're saying that there's only 140. I only have 140.
Yeah, I'm gonna have to look because my list
yeah,
don't start at 1.
40 because the first
Yeah,
3.
mine doesn't start until number 4. So if it's at 140 something, let's see.
138. 1, 2.
138. 138.
So should we try 138 then?
That was my very first thought. But then I thought, no, this answer is going to be in the data sheet somewhere. So we should try 138.
Wait. How far does yours guys go down to? It's down to 142.
Well, I'm trying to, let's see, so.
Yeah, mine starts at 4 and goes to 142.
Mine starts at 2 and goes down to.
So I don't think we take away 4. We take away 3 because the first 3 aren't being used, but 4 is being used. So I think
yeah.
it'd be 142 minus 3.
Yeah, so 139.
So it'd be 139.
Yeah. Thanks, Nathan. That's actually held me up on a couple of different problems.
139. So would you like me to try to submit mine and see how it goes?
Sure, it doesn't, you or me, or it doesn't matter.
Yeah.
I'll submit it and then see. Okay, 8 is correct. And 15 is correct. So we got 100%.
Sweet.
You got that,
So
Courtney?
Yeah, I'm trying to go back through and enter all my data. I'm on number 12.
So 12 is 94.86.
94.86. Okay. So
13.
the number 9 or number, what was it, 8 is the 139?
Yeah.
Yes.
Okay. Number 13 is 1.
Yep.
Number 14 is 1.
Right, because it's simple.
And number 15 is which one?
The first one.
The first one? Okay.
Yeah. You guys have trouble submitting yours? Mine won't go.
Okay, good job. All right, I
Mine's-
got it.
Mine submitted.
So Kelly, are you still doing the PowerPoints then for the final project?
Well, everybody needs to submit their own, but I don't mind compiling it.
Okay, because I'll try to get mine to you by the end of this weekend.
Okay.
So that, because I have a feeling it's all going to come to a huge head with the last 2 weeks, and so I'd like to try to get mine in and get it done. But if
Yeah.
you guys can get back with me, just kind of look through the data, describe the data, and make sure that everything's okay, I'll submit that tomorrow.
Okay.
So
All right, I will look at it, and then I'm gonna work on my PowerPoint too. So
is there an amount of PowerPoint, the PowerPoint things that we have to have? Do we have to have a certain amount? Do you know?
I don't know.
I don't know either.
I have no idea.
Did you find your puppy?
Like, we send that one PowerPoint as a group, but then we have to have our individual, like,
Is he in the office?
documents.
No, I'm just saying if he wants to.
So yours is coming up, Nathan. I bet you could probably get working on yours with all the information that's been sent.
Yeah.
You have to do the very last part. I'm not sure exactly what you have to do though. I think you have to do a paragraph. At least in mine, I had to do a couple of paragraphs, and then I had to do the histogram, and then I had to do box plot.
So Nathan, for you, it's gonna be totally words
Yeah, mine's just all words.
based on blah 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 blah. We should do this or not do that. It's recommended to you. Oh, hold on. Let me stop this broadcast.